Meet Mr. Gill, a businessman. In the beginning, production processes were limited. He is able to manage his production and make timely deliveries. Because of this, his clients are happy and satisfied. But as time passes, his business expands, he has installed more machines, and his production has increased. As the production increases, he is no longer able to manage his production, orders are not delivered on time, and his clients became unhappy and unsatisfied. Now that his business has declined drastically, he seems frustrated and angry about it. The problems faced by him are low productivity, mismanagement, unhappy clients, unorganized working, delayed production, wastage of time, wastage of resources. One day when he was thinking about all his problems, his friend Nina visits him. The problems he is facing due to the increased production, Nina explains how she manages her business using proper scheduling. Then Nina asks him to accompany in her production unit. There she points out how she is able to handle his production unit very well. Nina explains that for production to run smoothly, you need to plan the activities that are involved, create schedules that indicate which material is to be used to produce which product.
So what about scheduling?
Scheduling specifies when labor, equipment, and facilities are needed to produce a product or provide a service. With proper scheduling, Mr. Gill will be able to meet customer due dates, minimize job lateness, maximize machine or labor utilization, minimize idle time, minimize work in process inventory, and minimize time in the system. Did you know? Scheduling function differs based on the type of operation. Process industry, mass production, project, batch production. In scheduling, it is very important to know your responsibilities. Here's a quick illustration to that. Suppose this faucet is the demand of your customer. Every time there's a new order, it'll be put in here. As orders came, it will now be put into process. This time the management shall control and monitor the production process, and only those completed will be released. Now let's further elaborate that.
The first responsibility of the management is loading.
Loading is the process of assigning work to limited resources. The management assign the work to the employee where he works best, and each job to the machine that process it most efficiently. Under loading, we have the assignment method. It is a specialized linear programming solution procedure in deciding which worker to assign for a task, or which job to assign to a machine. Now, I'm gonna show you the procedure of assigning job. Suppose we have here 3 workers, and the number of days they worked in each projects. The first step we need to perform is the row reduction. We have to subtract minimum value in each row from all other row values. Therefore, if we reduced 15 by 9, we'll get 6 as an answer. Then we'll have to repeat the process in each rows. After that, the next step is column reduction. It is similar to row reduction. We have to find the minimum value in the column and subtract it to other values in each column. Now that we've reduced our values, we have to test it to get the optimum solution. Crossed out all the zeros. So the test for optimal is when the number of lines is equal to the number of rows, but in here it is not equal. So what we'll do is to get the minimum value in the remaining numbers, and subtract it to each numbers. Now that we get the answers, let's see if the number of lines is already equal to number of rows. After we got our optimum solution, we can finally proceed into making assignments to each workers.
While Mr. Gill and Nina are talking, Nina's phone rang. Her college friend is asking her if she's available to be a guest speaker this coming Saturday.
Oh, sorry I can't come. But I know someone who can be your guest speaker. I'll just refer you to her.
Saturday came, and Nina's friend, Miss Erica, agreed to be the guest speaker in the seminar.
Okay everyone, so when more than one job is assigned to a machine or activity, the operator needs to know the order in which to process the jobs. This process of prioritizing job is what we called sequencing. There are some priority rules followed in sequencing jobs. The most common are. To elaborate that, I will give you guys an example for each rules. Suppose you have the 4 jobs arrived for processing in one machine. So we have the start time. Guys, take note, if the start time of the first job is not given, consider it as 0. The processing time, due date and flow time. To get the flow time of each job, we just have to add the start time and the processing time. The question is, do all the jobs get done on time? The answer is no. Jobs B, C and D are going to be late because their flow time is greater than their due date. Let's proceed to EDD. We have to sequence the jobs by their due dates. First to be completed is the one who have the earliest due date. After we arrange the job, compute again for the flow time, then we'll get to see which one will not be completed on time. Here jobs C and B will going to be late. The next one is the slack. Arrange the jobs based on their slack time, which can be computed by subtracting processing time to due date. If there's a tie on the slack time, break it arbitrarily. We can see that jobs D, C and B will not be completed on time. Last priority rules we'll be discussing is the STP. Arrange the jobs by their processing time. Here jobs A and B will not be completed on time. Okay. So that ends our discussion. Anything you want to ask? Yes? Mister?
Mom, when are those rules may be appropriate to apply?
Good question, mister. There's a simulation study conducted to identify the guidelines for when certain sequencing rules may be appropriate. Number 1. SPT is most useful when the shop is highly congested. SPT tends to minimize mean number of the jobs in the system, thus, work in process inventory. By completing job more quickly, it theoretically satisfies a greater number of customers. Second, use slack for periods of normal activity. When capacity is not severely restrained, a slack-oriented rule that takes into account both due date and processing time will produce good results. Third, use date when only small tardiness values can be tolerated. And lastly, use FCFS when operating at a low capacity levels. FCFS allows the shop to operate essentially without sequencing jobs. When the workload at a facility is light, any sequencing rule will do, and FCFS is certainly the easiest to apply.
After the seminar, Roby and his classmates are tasked by their professor to do a summary of what they've learned about scheduling. At home, he started to summarize first loading, sequencing and then monitoring.
Hi. I'm Roby, and I'll be talking about monitoring. To help you understand the lessons, here's a brief discussion. Monitoring is related to reporting daily the progress of work in each shop in a prescribed pro forma and investigating the causes of deviation from the planned performances. Information gathered here must be up to date, accurate and accessible. Production personnel takes this information and transforms it into various reports for workers and managers to use. One of these is the Gantt chart. It is a chart that shows both planned and completed activities against a time scale. Main goal is to track the timeline and completion of a project.
Next is the input and output control, which monitors the workflow of individual work centers. It must contain the following: planned input, based on the operational schedule; planned output, use capacity planning techniques; actual input, it is compared with planned input to ensure that enough work enters the measured work center; actual output, used to identify possible problems in the work center.
Here is an example of input and output control chart. As we can see, control chart must also contain excessive queues or backlogs, which are one indication that bottlenecks exist. Speaking of bottlenecks, let us now proceed to the topic that concentrates on the bottleneck resource, which is the theory of constraints. Theory of constraint is a methodology used for process or quality improvement proposed by Liu Goldratt. Main goal is to remove barriers, or constraints, which also like to call bottlenecks. To fully understand the theory, for example, think of a bottled water full of marbles. As you try to pour out the marbles, only few comes out. It turns out the passage is too narrow for all the marbles to come out. In real production, it's not always that simple. but the basic processes are the same. You need to work until all the orders are completed, then move to the next. Step-by-step approach ensures that we improve throughput and eventually the profit. In theory of constraints, there are 5 focusing steps that we need to remember to remove bottlenecks and improve production. Identify the bottleneck. Is it a pebble or a boulder? Exploit the bottleneck. This means that we make a quick change. Subordinate. At this step you shift other people/resources around to support removing the bottleneck. Elevate. Figure out what else can be done. You might need to get a vacuum and suck out the leaves from the bottle. Repeat. This is a continuous process. Production improvement is never done. Now we'll be moving to employee scheduling. What are things need to be done to create a best work schedule for the employees? Know your team. Establish a team-wide communication method. Honor work preferences and time off requests as much as possible. Get employees to do some of the work scheduling. Let employees find their own substitutes. Create an availability chart. In conclusion, employee scheduling is often difficult because of the variety of options available and special requirements for individual workers. Just always remember, to win the marketplace, you must first win the workplace.